we start, first we may have a review of what we learned yesterday. So first, yesterday we talk about, first maybe that is TensorFlow. We use TensorFlow to create constant variables and also a graph, and we talk about how to feed input values into the graph and how to define placeholders to let the input value in, and we can use Finch, this mechanism, to pick up to check some values, some nodes values, and then we'll talk about how to save models, and we will use tf.train and this tf.train saver to save models, and we can restore models, restore the structure of a graph and also the parameters, the value of these variables in the graph, and then we can use it directly. So that is the TensorFlow part. And then we talk about the deep learning part. So first, what is learning algorithm? We talk about the experiments to us human beings, just like data to the algorithm to these models. So we have a specific task. So the model would have some specific algorithms, strategies, principles, and according to these principles or strategies, it can learn from the data, just like us, just like human beings. It can learn from experiments, and then they will be output some prediction or the performance. And here's the comparison between the human learning process and the learning algorithms for models. And usually for machine learning process, we will divide the machine learning process, how to create machine learning models and how to deploy machine learning models, train machine learning models. We can divide the whole procedures into 1, 2, 3, 4, 5, 6, 7 steps. First, we need to collect a lot of data, and then we need to do data cleaning to drop some non-values and to drop some and to clean some dirty samples, and then we need feature extraction to check which feature is important and which feature is not that important, and we need to check the correlation between features, and we may need to select feature and extract features to convert maybe 10 features into 3 features using some feature extraction method or algorithms like PCA or other algorithms. And then after that, that is the process, that is the data pre-processing process, and then we can start training. We can start training the model. So here's model training, the step after the model training step. If you are satisfied with the accuracy, with the performance of the model on training data set, so here comes to the next step, that is model evaluation. So for model evaluation step, we got a test set, and there are some new samples that the model never seen. So here we will test these new samples on the trained model and to evaluate the performance of the model with these new samples. And if we found that the model don't have the problem like overfitting or underfitting problem, so we can deploy the model. We can integrate the model to the edges, or we can deploy the model to cloud as an API. So that is then the users can use the model to make predictions and to do image classification. Maybe there are some problem or there's some feedback, and during the model deployment, they stop, it become a product, and we will receive some feedback, and we will collect some more samples. So this sample can be added to the training data set to train the model again and to make the model more intelligent. So that is the machine learning process to create a model, to do data cleaning, to do feature selection and extraction, to train the model, to evaluate the model, and then deploy the model. And then we will receive some feedback, and we will receive some feedback, and we will collect some new samples, new data, and we can add this new data to training data set and to make the model more intelligent. So that is the training process. And then we talk about some basic terms and concepts in machine learning. First, we talk about the data sets. Usually, for machine learning or deep learning model, we can divide the data set into 3 types. The first is training data set, then the second is validation data set, and third is test data set. And here we talk about training data set and test data set in detail. So here we can divide the whole data, the samples, into 2 parts. The first part is training data set to train the model, and the test data set is responsible to evaluate the performance of the model. So here, and for every sample, it got a lot of features. And for supervised learning, these are samples with label. For unsupervised learning, these are samples without label. So that is training set and test set. And then we talk about the tasks of machine learning. We can divide these tasks into 3 categories. The first is classification, and the second is regression, and the third is clustering. So for classification, like image classification, the outputs are discrete values like 0, 1, 2, 3, 4, 5. For regression, the outputs are continuous numbers like maybe like 100.1, 100.2, 100.3, 100.11, like this. And for clustering, always clustering models or algorithms are unsupervised algorithms. We need to find the internal similarity between samples, and we want to cluster similar samples as the same group. And then we have a review of the types of machine learning can be divided into 4 categories: the supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. We talk about these 4 types of learning over and over again. So here, just pay attention to about these types of machine learnings. And then another term, we talk about what is overfitting, what is underfitting. So here is underfitting model. So that for overfitting, underfitting, we always talk for these 2 terms. We always talk about, we use these 2 terms to describe models rather than data sets or samples. So for underfitting, the reason is that the model is too simple compared to the training samples. It cannot generate the trend of the samples very good. It falls to null features from the training samples. And for overfitting model, the model is too complex compared to the training samples. So here is an example. It knows everything. It knows every detail, even the noise from the training samples. That is overfitting problem. So for overfitting model, we may get a very high accuracy or very low value of loss functions in training dataset. But when the model meet some new samples in test data set, performance will be very bad and the accuracy will be very low. That is an example of overfitting problem. So for underfitting problem, so maybe it fails to, the model will fail to get a very high accuracy even in training data set. So that is the capability of the model, or that is overfitting and underfitting. And this picture in between is a picture to show a model just fit right with the samples. And then the next section, we talk about some commonly used machine learning algorithms. So first algorithm we talk about is linear regression algorithm. So linear regression algorithm of course is algorithm to solve regression problems. So that is the output value will be continuous value, continuous numbers. And here for linear, what linear, this linear mean we will use linear model. So linear model like this WX plus B, we will use this linear model to make predictions. And here is an example. So this is the straight line linear model in 2 dimensions. And here these blue spots are samples. And for linear regression, here is our model. It's just this equation. And here is the actual label. That is y equal to wx plus sigma. Here sigma is an arrow, that is the noise, because there are a lot of noise in practice. So here sigma indicates the arrow or noise, and this is the prediction and this is the actual label. So to compare the difference between the actual label and the prediction, we would use a loss function. So here is a loss function. Usually we will use mean square arrow, the loss function for linear regression. And here is a loss function, and our aim is to minimize the value of the loss function during the training process. So that is linear regression. This is the equation linear function for linear regression, and this is the actual label, and then we got a loss function to evaluate the difference between prediction and the actual label. So our aim is to minimize the value of loss functions so that the prediction will be equal to the actual label. And then we talk about logistic regression. So here's minus. So logistic regression actually it's not a regression model, but it's a classification model. So it's logistic regression as a model to solve classification problems, to solve binary classification problems. That means the output will be either 1 or 0. So here is the function of logistic regression. And then we talk about clustering algorithm. We call it k-means. For k-means algorithm, here this k is a hyperparameter, and k means k clusters. That means we want to divide the whole samples into k clusters. It's a hyperparameter. So the first step for k-means algorithm is to decide the number of k. You need to choose the number of k. And here we may have a review of the k-means algorithm step by step. So first we choose the number of k, and then we randomly choose k points as the central points of each group. So here here are a lot of samples, and if k equal to 3, so that is the first step. Decide the number of k and k equals to 3. Now we want to divide these samples into 3 groups. So then the next step we're going to do is to randomly pick 3 central points for each group. So here we randomly pick. For example, here we randomly pick 3. Wait a second. We randomly pick. Oh my God. We randomly pick 3. Wait a second. How to make it to okay. Okay, we randomly pick 3 central points here, 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 and then we will cluster. We will compute the distance. For example, this. For example, here, this sample, we will compute the distance between this sample to the first central point and second central point and the third central point and choose the shortest distance and assign this sample to this cluster, and then we can assign all the samples to the 3 cluster correspondingly. So here we here we designed three clusters here, here, and here. So that is the third step. So the fourth step is we need to recompute the central point for each group. So we recompute, we update the central point for each group. That means for this group, the central point may be moved to here. The central point may be moved to here. The central point may be moved to here. And then we will repeat step 3 and step 4 until maybe the central point do not change. If we find that the central point do not change when we update the central point for each group, if we find this central point, all the central points stay the same, so we can stop the interactions. And then the second example to stop the whole procedures, maybe if we find all samples, all points remain in the same cluster, remain in the same group, we can stop training. So that is a process for k-means. So k-means is a clustering. So k-means is a clustering algorithm, and it's an unsupervised algorithm. And k is a number of clusters, and we need to decide the number of clusters for the first step. Any question? Okay, if there's no question, we would continue. And maybe then the next algorithm we're gonna talk about is KNN. So here KNN means k nearest neighbors. Here this k is also a hyperparameter. So the next algorithm we're gonna talk about is KNN. Here k is also the hyperparameter. It's also a hyperparameter. We need to decide the number of k, and for KNN, this kind of algorithm is a classification algorithm. It's a classification algorithm. It's an algorithm to solve classification problems. And we may have a view of how KNN, this kind of algorithm works. And for example, here, we got a lot of samples, these blue samples, these green samples, and these orange samples. So if we have a new sample, and one thing we need to be careful is that for KNN, we don't need to train the model because KNN don't have any parameter except for these hyperparameter. You don't have any parameter, and it's supervised learning algorithm. So every corner means one label. So that is maybe group 1, group 2, group 3. So when a new sample come, and if here k maybe equals to 2, if k equal to 2, that means for this new sample, we will find the first 2 nearest samples in this among these samples. So for this sample, the nearest 2 samples are this one and this one. So here, this new sample will belong to the yellow group, That is how KN works. So another example, for example, if K here equal to 6, so here a new sample come and we will find the 6 nearest samples for this new sample. So that is this point, this point, this point, this point, this point, this 6 points, and then we will find that in these 6 points, so there are 3 orange samples and 2 yellow samples and 1 green sample. So this new sample will belong to the orange group. So that is KN. We don't need to train the model. We just need to find the K nearest labels, and it's a model for classification. And also it's a supervised learning algorithm. These models are all label models. So that is KN, very simple algorithm. And then another algorithm we're going to talk about is decision tree. So what is decision tree? Any idea? So any volunteer would like to explain why is decision tree and how maybe decision tree works? Just give some simple examples. So here we're going to talk about decision tree. So is decision tree a supervised or unsupervised learning algorithm? Is decision tree an algorithm for clustering or for regression or for classification? So is decision tree, first decision tree is of course it's a supervised learning algorithm, and we will explain how decision tree works later. And then for decision tree, it can solve both regression and classification problem. So it can solve both regression and classification problem. And there are a lot of different decision trees like ID3, C.5, or maybe chart and a lot of decision trees. So here chart means classification and the regression tree. So here this chart means classification regression tree. So we will just explain decision tree step by step, just a simple explanation of how decision tree works. So here, this tree, the name of decision tree, this tree means decision tree actually is a tree-like structure. It's a tree-like structure. It's a tree-like structure model, and it's a model to make decisions. It's a model to make decisions, and we can decompose the decision tree into we can decompose the data into a lot of subtrees. So here maybe we can have you see some examples. Clean. And every day we make decisions, maybe like a tree like structure. For example, how can I get to work this morning? So how can I go to the working place this morning? By maybe there are several choices, maybe by taxi and by bike and by walk. How can I go to my company this morning? By taxi. So T means by taxi, and by walk or by bicycle. Okay, so the first thing I will consider is about is the time, is if it's a time is sufficient or not. If the time is not sufficient, I'm gonna be late, so I will choose taxi. So I will go to the company by taxi. So if the time is not sufficient, maybe if the time is not sufficient, maybe I will think about the weather. I will consider about the weather. So I will consider about the weather, if it's raining or not. If it's a raining day, yeah. So the only choice maybe for me is to go by walk. If it's not raining and I got sufficient time, so maybe I will go to my company by bicycle. So if it's not raining, I will go to my company by bicycle. So that is an example of decision tree. So every day we make such decisions like this tree structure model. So let's have a view of how to create a decision tree model step by step. So for example, the first step is we need to determine or decide the the decision column. So first we need to decide the decision column, and then we need to calculate. So there is a lot of things we need to take into consideration. So that, for example, the weathers, we need to, maybe there's a lot of features like the weathers, the weather and the time, and what kind of shoes you are wearing. There's a lot of features, and which feature you need to take into consider first, which feature is the most important feature, which attribute is the most important attribute for the decision-making system. So we need to consider, we need to calculate the for example, the entropy for the classes. That means we need to calculate the entropy for the classes, calculate for the maybe entropy for all these classes, and then we need to calculate the information gain for each split. So we will try, if we split the whole samples according to this attribute, what will be the information gain? So we need to calculate the information gain. Of course, we want to choose the attribute that with the maximum information gain. We need to calculate the entropy for maybe first for other attributes after splits, and then the fourth step is to finally calculate the information gain for each split. Yes, so sorry. So for these two steps, the purpose for these two steps is to calculate the information gain for each split. So our aim is to make each substring as pure as possible. So here we need to calculate information gain for each split. We need to check if we split all the trains according to this attribute, what will happen and what will be the information that's left. So the information gain is calculated from the split, use each attribute, and then we will choose, that is the 5 step, we will choose the attribute with the largest information gain. So the attribute with the largest information gain will be used for the split this time. So after we decided the attribute to use, so next step, we will perform the first. We will perform the first split. We will perform the first split. So the whole samples are being divided into two subtrees, or into 3 subtrees, or into 4 subtrees. It depends on the attribute. If there maybe for the attribute like the weather, it can be raining, it can be cloudy, and it can be sunny. So if we use this attribute to split the whole samples, the whole samples will be divided into 3 subtrees. The first one is the raining subtree, the second one is the cloudy subtree, and the third one is the raining, cloudy, and sunny subtree. And then the 7th step is we will continue to perform. We will continue to perform further splits. Here we complete the entire decision tree. So that is a step to create a decision tree. Decision tree is wait a second, we will go back to the slides. The decision tree is a tree-like structure to help us to make decisions according to the attributes. And first, we need to find some important attributes. That means the attributes contains most of the informations, and so we will calculate the information gain after each split and choose the attributes with the largest information gain. So if we split the whole samples according to these attributes, we will get the most information gain, and then we will continue the splits till the whole decision tree were completed. This is just an example of decision tree. There are a lot of decision trees, and we can choose the best attributes, maybe according to information gain or according to another criteria like Gini. A lot of, and here maybe we would move to another machine learning algorithms. So maybe this is the last, this is the last machine learning algorithm. So here, the last machine learning algorithm we're gonna talk about is SVM. So SVM is for support vector machine. So we will go back to this. So we will talk about support vector machine. So what is support vector machine, or what is the goal for support vector machine algorithm? So let's maybe use this graph, use this figure as an example. Here we want to do 2 binary classification task. So for binary classification task, this green spots means maybe green, oh no, red spots means the women, and this blue spot means men. So we need to divide these 2 categories. So we need to divide 2 categories. So we want to draw a boundary. We want to draw a boundary between these 2 categories. There are a lot of possible boundaries like this, maybe clean or okay. We got 2 categories. The first class, we got the first class, and we got the second class. Okay. 2 classes, and our goal is to draw a boundary between these classes. So like here, a boundary like y equals to wx plus b. So if the point is dropped beyond the boundary, that is, if wx plus b is larger than 0, so the sample will belongs to this class. If wx plus b is smaller than 0, the boundary will belongs to the class. The sample would belong to this class, but there are a lot of there are a lot of possible boundaries, right? we can draw this straight line like this, like this. There are a lot of possible boundaries, and how can we find the best boundary to separate these two classes? So that is the question that support vector machine wanna discuss. So for support vector machine, the goal for support vector machine is actually to find the maximum margin is to find the maximum margin between these two classes. So that is a goal of support vector machine, to find the maximum margin. That means, in another way to make it more straightforward, that is to find the widest road between different, or between two different samples. So that is a goal of, yes, please.
By samples, you mean the clusters we have made, like 2 different clusters from
Yes,
sample?
yes, between different classes, maybe.
All right, thank you.
So that is, we need to find the maximum margin between these two classes. So why we also call it widest road approach. That means here, this line, these two red lines, and this black line come together just like a road avenue. A road here is the boundary of the road, and here is the middle. Here is this straight line lies in the middle of this road. So we want to find the widest road approach. That is support vector machine to make the margin as large as possible between two classes. And it's a model. Of course, it's a supervised machine learning algorithm, right? And for support vector machine, it can both solve like classification, like decision tree. It can both solve classification, and it can both solve regression and classification. It can both solve regression and classification problem. And another key point about decision tree is the kernel. So why is kernel? For example, why we need kernels in support vector machine? For example, we'll clean off. For example, here are two classes like this. This is class 1. And these are class 2, right? We got two classes, but in 2 dimensions, we cannot use a linear model to solve this problem. We cannot find the widest road between these two samples. So for SVM, it's linear unseparable. This sample is linear unseparable. So here we need use kernel. So here we need use kernel to convert these samples from 2 dimensions to higher dimensions. Like this, if we use the kernel trick, these are samples in 2 dimensions, and we can convert these samples into 3 dimensions like this. So if these samples in 3 dimensions, we can use a hyperplane. We can use a hyperplane, which is a linear boundary in three dimensions. We can use a plane, which is a linear boundary in 3 dimensions to separate these 2 classes. So that is the kernel trick for support vector machine. As just a simple introduction to support vector machine. For example, there are a lot of other details in support vector machine, but here we're gonna just talk about the main idea of support vector machine and the main idea of the kernel tricks. So, okay, where are you? So that is all the commonly used machine learning algorithms we talk about. So first, we may have a review. First, we talk about linear regression. So here, where is linear regression? So here, linear regression. Linear regression, of course, is a supervised model, and we use linear equations to generate the trend of the samples, and the output are continuous values, and it's for regression tasks. And here the next is logistic regression, and this is an algorithm not for regression problem, but for binary classification problem. The output will be 0 or 1. And here, logistic regression is also a supervised learning algorithm. And the next algorithm is k-means. And here, k is hyperparameter, and it's unsupervised algorithm, and it's a clustering algorithm. And here is k-means state by state. And then we talk about KNN and KNN as an algorithm without parameters. So we don't need to train. We don't need to train KNN, and K here, KN means K nearest neighbors. So we need to find the K nearest neighbors of the new sample and decide which class the new sample belongs to. And it's also a classification model and supervised learning algorithm. And then we talk about decision tree. So for decision tree, it's a tree-like structure. So the most important thing for the decision tree is to find the best attributes to split these samples into different sub-trees. And here is an example of decision trees step by step. So for decision tree, it's a supervised learning algorithm. We need samples with models to train a decision tree model. We need samples with labels to train a decision tree model. And for decision tree algorithm, you can do both regression and classification tasks. And the last one we're going to talk about is SVM. So first, SVM is the goal of SVM is to find the maximum margin between 2 classes, or we can see in another way to find the widest road between 2 classes. So here, how to find the widest road? why we call it support vectors. Maybe we can have a view to decide it, the boundary, the classification boundary of these two classes. So only the samples on these two red lines that matter. So these samples are not important. These samples are not important. These samples here are not important. But this sample on the side of the road, that is the sample that matter. That is the samples that matter. So we call this sample support vector. We call it this sample support vector because we use vector to compute, and we call this sample support vector. So these are the samples. The support vector are the important samples to determine the final classification boundary. So that is support vector in SVM, and it's a supervised learning algorithm, of course, and its algorithm can both solve classification and regression model. And then we talk about the kernel tricks for support vector machine. So the main goal for the kernel is to convert a linear unseparated samples into linear into a data set, into a data set, into a data set that can be separated linearly. So one typical example is that we can convert these samples into higher dimensions. We can convert these samples into higher dimensions so that the samples can be separated linearly. So that is all the commonly used machine learning algorithms we would introduce for this HCIA-AI training. And for the exam, we need to focus on the main source, the principles of these machine learning algorithms. And here are, so that's all for this section. Maybe we can have maybe 10 minutes rest, and then we will continue to talk about hyperparameters and the overview of deep learning, and then maybe, so 10 minutes break. So we will continue. So move to the next section. We're going to talk about the hyperparameters and the validation state. And maybe here's some question. I received some question about the maybe the important. Someone asked about the important parts for the certification exam. So for the certification exam, you need to focus on first the Python chapter and the TensorFlow chapter, and most important, of course, is So here I will write down here. So you need to focus on the Python chapter and the TensorFlow chapter, and of course the most important is the machine learning and also deep learning chapter. That is the important part for certification exam. And some of you ask why we just skip the math part. There are two reasons why we skip the math part. Maybe the first reason is the time. The time is limited. We only have 3 hours every day, so we cannot talk about math in details. And so that is the first reason. And the second reason is that if we talk about math online, we talk about math online, we talk about linear algebra, so we talk about eigen decomposition, eigenphases, and we talk about these equations, and it will be very, very, very boring. And so that is maybe the second reason. And the third reason and most important reason is in the certification exam, there are just a few questions from the math part. These few questions are very, very, very simple. So these questions, for this question, you need to focus on the MOOC exam. There's a MOOC exam I've showed to you guys. Maybe the first day, you need to focus on the MOOC exam to pass the certification exam. There are 60 questions in total, and in the exam there are just maybe one or two, maybe one, maybe two questions from the math chapter. So we're not gonna spend 1 or 2 hours to talk about the math chapter. And these questions are very, very simple. So you just view this math chapter as a reference. And so that's the reason why we skip this math chapter. And the time, the limited, and the exam, there are just a few questions. And also for this math chapter, you need to focus on the quiz after the math chapter. So in the white slides, you at the end of the white slides, every chapter you will see some questions, and you need to be careful about these questions. This question will be very similar to the questions from the certification exam. So the key part for the certification exam is these 3 parts. And for the lab exam, of course, for the lab exam, you need to focus on these 2 parts, the Python part and the TensorFlow part, and focus on the daily test I've sent to you guys, the first daily test and the second daily test. And also for the lab exam, you need to be focused on the image recognition recognition. You need to focus on the image recognition hands-on practice, and we will talk about this image recognition practice maybe tomorrow. And so for the exam, focus on these 1, 2, 3, these 4 parts. And so for the presentation, just choose the topic you like, any topic related to AI. So that is the key parts for the certification. And for the time you take the certification, maybe 1 or 2 weeks later after the training session, that is 1 or 2 weeks later, that is the end of May, maybe the end of May, you need to take part in the certification exam. It will, you have some time to self-study by yourself. And so we will continue to.
I'm sorry, I have a question.
Yes, please.
What's the criteria to pass the exam? You know, how much marks do we need to score in the test?
Okay, you mean for, okay, I will explain. So for the certification exam, that is the HCIA-AI exam, sorry. The full mark. The pass mark is 600 out of 1,000. Okay, that is the pass mark. That is a full mark. And for the lab exam, you need to get 900 out of 1,000. So.
Oh, so we have to
Okay.
clear both of the exams to get certification.
No, there are two. Actually, there are 2 exams. First is the certification exam. We call it HCIA-AI exam. That is a certification exam. So here we got the second exam. This exam we call it HCIA exam. This is the exam for instructors. Yes, this is the exam for instructors. So this HCIA exam actually contains 2 exams. The first is the lab exam, and the second is the presentation. So it contains 2 exams. So actually, you need to pass three exams. So for the presentation, the pass mark is also 900 out of 1,000. So 3 exams. And for the certification exam, the duration may be 1 hour and a half. And for the lab exam, the duration is also 1 hour and a half. And the presentation exam, the 1 hour and a half or 2 hours. I'm not sure. 1 hour and a half or 2 hours. And for the presentation exam, you have to pre for about 1 hour. And after your presentation, maybe 3 to 5 questions will be asked. So that's all about the exam.
The part is also for the instructor.
Yes, the presentation also for the instructors.
Thank you so much.
Okay, thank you. Any other questions about the exam?
I want to ask that about the lab exam. So
yes, please.
I can comprehend what type of questions will be there in lab exam. Are they going to be like us developing machine learning models, or like if you have a sample for the lab exam, it would really help us to understand what to expect in the lab exam.
Okay, for example, no, I don't have any sample about the lab exam, but I will give you some examples. For example, there are simple questions, and there are 1 or 2 questions that will be a little bit difficult. So maybe these maybe there are 20 questions in total. If I remember correctly, there are 20 questions in total. And maybe 80 or 19 of them are very simple questions, like define to use TensorFlow to define two constants and do multiplication and check the value of the output, and question like that. Maybe they will ask you to define two variables, or you will be asked to maybe do matrix multiplication between two constants or between two variables, and use station to get the output of the final result. So question like that, 18 or 19 of them will be questions like that. Or you need to print something, like for example, print hello world. Maybe that is the first question of the lab exam, print hello world like this. And maybe you need to define a list and change some elements in the list, or you need to change the data structure of the list from a list to other, maybe. Yes, please. Any other question? So that
कल का दिन तुम मेरा नहीं करके दे सकेंगे और किसी को। हाँ होता है तो मैं बताता हूँ।
If you don't have any question, please mute yourself. Otherwise, we will hear some noise.
Yeah, I have a question.
Yes, please.
We have to write the lab exam code in Jupyter Notebook or maybe in Word, MS Word.
In
Jupyter, we have a lot of help.
So for the lab exam, what
function we will use?
Yeah. Go ahead, pardon, because there's some. Please unmute yourself if you don't have any question.
वर्किंग करते हैं, उसके होगा तो बता दो।
Okay.
ठीक है, thank you.
I have one question, Kelsey.
Yes, please.
Like we give the normally certification exam, it is conducted in the View Testing Center or online proctored. So lab exam is conducted by some panel, or it is the same like we have experience of View Testing Center.
Okay, for the lab exam, you will maybe get a Huawei cloud account, and maybe I will show you. Sorry. Maybe you will receive a Huawei account, the name of the account and also the password of the account, and you need to log in. You need to log in the Huawei account and finish the exam online in Huawei account, in Huawei cloud.
Okay, so there might be some or what about the presentation? It is conducted by some panel or some trainers are there who should ask any question?
Yeah. There will be trainer and one or two of my colleagues, and they will listen to you, and you will pray for 1 hour, and after that you will be asked some questions and you just answer these questions. So that is a pre. And for the lab exam, you will receive a Huawei cloud account, and you log in and use a Jupyter Notebook. You open the Jupyter Notebook and you will find a lot of questions, and then you just program here. There, okay. That is okay. Okay. Any other question about
also
the
like with respect to presentation, like we can take any topic like like TensorFlow or like any machine learning of our choice,
Yeah.
and we can make a presentation onto that.
Any topic related to AI, any AI topic.
Okay, thank you.
Okay. Any other question?
Yes, two things. One is that I think we cannot have a cloud account here in Pakistan. So how are we going to manage that? And
it doesn't matter. It's not a private account, but official account. So it give to we will give this account to you, and you just the account is just for once. It will be expired after the lab exam.
okay, and you just talked about a mock exam. Can you please share it? We are unable to find it.
Okay, I will really share it. For wait a second. I will need to find the email. Wait a second. Okay, here. I'm trying to find the email. There will be a lot of links. Wait a second. Where is the email? You can find the email. We've already sent you an email, and you can find a MOOC link, MOOC exams link. Wait a second. There's too many emails.
I have a question. When will this exam will be held? Like on what date? Are the dates decided or will they be announced later?
It will be announced later. Maybe you can connect to the local manager and ask. And she told me that the exam will be arranged maybe 1 or 2 weeks later. 1 or 2 weeks later after the training. After the training, maybe in the end of the May.
Okay.
Okay. Any other question?
So see, if we clear the certification exam, then how much time is for the instructor exam? Is there any time limit, like we have 15 days or 1 month to clear the instructor exam after clearing our certification?
You mean after certification, the
Yes,
time
yes.
of the exam?
Yes.
Or
If we clear the certification exam, then in how much time we should attempt the instructor exam as well?
I'm not sure. Maybe one or 2 weeks later. Anytime you ready for it, maybe you can ask from your local manager. Maybe.
Okay. I am asking because of that there might be any time limit that we should complete this course and the training in 1 month, 2 months, or 3 months, like that.
Okay. You can check. You can check the date about the certification exam and the exam for instructors with the local manager, with Fatima and Bilal.
Okay. Thanks.
Okay, thanks. And here's an email. Here's an email. So for the MOOC, here is a link. That is a MOOC link. Click this link. Okay, I will open this link. Use the search engine. Wait a second. Here is our course. So you click view this course. So here is a category. Here is a general thing, because you just skip all these online course and jump to the final exam. So here is a final exam, and you can have a view of the pass score, 100, no, 600, and the duration, and start the exam. So you will see these are the questions. So that's the MOOC exam. And to pass the certification exam, you need to maybe practice. You can practice with the MOOC exam. And any other question about the exam?
So that's a mock exam that you just showed, right?
Yeah, there's some MOOC exam, and you can check this email. You all received this email, I believe. This
Yes.
email. Yes. And here's a link. Click this link, and you can find the
Thank you.
online course. Yeah. Any other question?
Just to confirm, we have one certification exam that will be like multiple choice question or the mock exam that you have shared. And then
Yes.
there will be a lab exam that is for instructors only, and a presentation, and that is also only for the instructors. Am I right?
Yes, correct.
Okay, thank you.
Okay, thank you. Any other question? Okay.
The certification exam will include questions from the slides and as well questions from the lab work, right? Like basics from TensorFlow and basics from
Yes,
Python.
yes.
Okay.
So we will continue to talk about the hyperparameters and the validation state. So for the hyperparameters, we've just not just we've introduced what is hyperparameter. Hyperparameter is types of parameters that can only be obtained based on our experiments. So unlike these parameters can be obtained, can be learned from data, this kind of parameters cannot be learned from data, usually cannot be learned from data. And here we've made a lot of, we've used a lot of examples to explain why it's hyperparameter, just like K in Kn, and the K means this K in K means these are all hyperparameters. So here are some commonly used algorithms, search algorithms, to find some proper value of these hyperparameters. So the first is research, and we're going to introduce the first two, research and the random search. These two search are the simplest two search algorithms for searching for the hyperparameters. Okay, the grid search and the random search, so we will maybe explain here. So for grid search or random search, how they search for the proper value of hyperparameters. For example, here we got a hyperparameter K, and we decide the range of K or some candidates of K, just like K maybe equal to 1 maybe equal to 10, maybe equal to 1,000, maybe 100 or 200. And so that is research. And then we got another hyperparameter, maybe here this is b, so b may equal to 0.1 or 1 or 10 or 20 or just like this. So for this model we got two hyperparameters, and we decide, we choose some candidates. So here, these two.
Kelsey, please share your screen.
Oh, sorry. So here we got, for this model, for example, we have a machine learning model, and for this machine learning model, we got two hyperparameters. The first is k, and the second one is b. So maybe we will decide the range of k, some candidate of k from maybe 1, 10, 100, and 200. That's some possible value of k. And for b, the possible value of b may be 0.11, 10, or 20. So here we can use grid search. Clear all. So we can use grid search. The first, we change a comment. The first is k. So the second hyperparameter is b. They all got some possible values like 0, 1, 10, 100, and b got some possible values 0.11, 10, 20. So there are different pairs of k and b, This is a matrix. So that is grid search. So the model would try every pair of k and b and choose the pair with the best performance. So that is grid search. And for random search, maybe first thing we decide the ranging of k, the range of k and the range of b. Maybe k would range from 0 to 100, and b may range from 0 to 1, and there are a lot of possible pair of k and b. So the model would random pick a pair of k and b, and to check the performance, of this pair of hyperparameters, and choose the one with the best performance. So that is grid search, and that is random search. And to check to find the proper value of hyperparameter, always we would use a data set. We call it a validation set. So first thing, why is validation set? So here we got the entire data set. We collect a lot of samples, and we do data cleaning, we do feature extraction and the feature selection. Here is the samples. These are all cleaned samples, structured samples, and the entire samples. We can divide these entire samples into first two parts. The first is training part, and the second is test part. So we separate these two parts, and then the validation set comes from the training set rather than the test set. So then the validation set comes from the training set. So when we train the model, the validation set just like a monitor. So we train the model use the training set. So the training set would find the proper value of hyperparameters, the training set will try to minimize the value of the loss functions. So that is the aim of the training set, to make the model work. And the validation set always work like a monitor, always work like the monitor. So after every epoch, so we train the model for the first time, and after the first training, so the validation would check if the model have some problem or not. For example, like if the model is overfitted or not, it will check. And also validation set is set to find the proper value of hyperparameters. For example, if the first time we trained the model for the first time, and we trained the model for the second time, and the validation could compare the maybe value, the loss value, or compare the loss value of these two times and adjust some hyperparameters. So validation set always work as a monitor during training, and we use training set to train the model, and validation set to monitor the performance of the model, to find some proper value of hyperparameters. So that is a validation set. And to make full use of all datasets, as we mentioned that we don't use this validation set to train our model. So in order to use the validation set to train our model, we would introduce another method to separate our training dataset, that is K4 cross-validation. So K4 cross-validation, how it works. For example, for K4 cross-validation, here K is also, we can view it as a hyperparameter. So for K4 cross-validation, here is a test set, and here is the training set and the validation set. For example, K equal to 5. If K equal to 5, that means we will divide these samples into 1, 2, 3, into 5 parts. So equally divided these samples into 5 parts. So for the first time, the first part would be maybe the validation part, and the rest of the 4 parts will be the training part, the training set. And then we will use these samples to train the model, and maybe we can receive an accuracy. And the next time, the second part, the second subset, this part will be the validation part, and the rest of these 4 parts, this is always test set, and the rest of the 4 parts are the training part. Then this is the validation part, and we will receive an accuracy. And so we will train the model 5 times. So for the third time, the part 3 will be the validation set, and for the fourth time, then part 4 will be the validation set, and for the 5th time, the last part will be the validation data set, and the rest of the 4 parts will be the training data set, and all receive an accuracy, so that we can fully use all the samples, and then we received 5 accuracy, and then we take the average, and then we take an average of these 5 number, and here the output is the final accuracy of this model. So that is the K4 That is the K for cross-validation. So that's all for the hyperparameter and validation set. So next the next 1, 2, 3 section is about the parameter estimation and maximum likelihood estimation and the base estimation, and you can just skip. You can just skip these 3 sections, and you will not see any question from these 3 sections. So we just ignore them. You will see there's no question from these 3 questions. You just ignore them. And so now we're gonna move to the most important part of deep learning. That is, we're gonna talk about neural networks. Finally, we're gonna talk about the neural networks. So
I have one question here.
Yes, please.
Can we change parameters during validation?
You mean change hyperparameters during validation? Yes, you can change hyperparameters. For example, you can change maybe the learning rate. We will mention about these hyperparameters. So use the validation set. It's validation set like a monitor. So it will change the value of these hyperparameters during the training process.
Okay, I have another question. In some cases, we normally partition the data into training and testing only.
Yes.
So in that case, do we use validation or not, or only just do the training and testing?
It depends on your data set and also your model. If the problem you want to solve is not that complex, and the model just contain one or two hyperparameters, you don't need validation set. But always for deep learning models, we will always use validation set to monitor the training process of the model. So for deep learning models, we will always use validation set, and it also depends on the number of your samples you collect.
Right. Thank you.
Okay, thank you. So for deep learning overview, because our time is very limited, we need to hurry up. And here, the deep learning, the definition of deep neural networks. So first, the neural networks in deep learning is from the neurons from in our brain. Here is the structure of the neurons from our brain. For example, here is a single neuron. This neuron, we will take this neuron as an example. This neuron first will receive information from the last neuron. So it will receive information from the last neuron. So this 1, 2, 3, 4, these 4 will be the input for this neuron. So here we make some input, and here with BIOS, you can consider BIOS as noise. And here 3 inputs and with BIOS. So here is a cell, and these cells are responsible to process these inputs. So to process these inputs, so here we just use weighted sum. We just use weighted sum to process this input, and then the output will be transferred. The output will be transferred to the next neuron. That way, as the output will be transferred to the next neuron. So that is an example of the neural, and we use equations. We use equations like this This is the equation. We use equations like this. Here we got 1, 2, 3, n inputs, and then we will take the weighted sum, that is x0 times w. No, that is x0 times w1. No, this is not x0, but x1 times w1, x2 times w2, xn times wn plus bios, and then that is a weighted sum, and then always we will use a activation function. So here we use an activation function. This activation function is a sign function. That means if the input is larger than 0, the output will be 1. Otherwise, the output will be -1. So that is the activation function. So the activation function, the goal to add the activation function in perception in neurals is to add the linearity. They add the nonlinearity of the model. Because if we don't use this activation function, the model will be a linear model. It's just weighted sum, right? Just like the linear regression, just weighted sum. We just combine a lot of linear regression model together. So we need to add activation function. So this model will be a nonlinear model. So this is an example of the neurals, and we can combine a lot of neurals together. There are 1, 2, 3, 4 inputs, and these 4 inputs could be inputs for this neural, for this neural, for this neural, and we call these layers between input layer and output layer. We call this layer hidden layer, because we can add a lot of hidden layers. 1, 2, 3, 4, 5 hidden layers or more hidden layers. So that's the reason why we call it deep learning, because the network is very deep. It contains a lot of hidden layers, and in each hidden layer, we can add a lot of neurals. Each hidden layer can contain 5 neurals, 10 neurals, 100 neurals. So that is an example of deep neural networks. So here we will have a look of the most simple neural network. We call it perceptron. So here is an example of perceptron. We got several input neurals, and the output is just 1 neural. The output is just 1 neural. That means the output will be just 1 output. So we do weighted sum of these all inputs, and through an activation function comes to the output. So for this perceptron is still as a model just for classification, linear classification. So it's a model just for linear classification. Like this, the straight line in 2 dimensions and a plane in 3 dimensions. It's still a linear classification. So it can only draw 1 straight line in 2 dimensions. So that's the reason why it cannot solve XOR problem. Here is an example for XOR problem. If x equal to 1 and x equal to 1 and y equal to 1, this is the white point. X equal to -1, y equal to -1, this is a white point, and otherwise they are black points. So to divide these 2 classes, we need 2 straight lines. So these are unlinear, or we need this draw a circle. We need 2 straight lines, or we need to draw a circle. It's unlinear problem. So, but perceptron is a binary classification model, so it cannot solve XOR problem. So that is a problem of perceptron. So to solve the XOR problem, we need to add neurals. we need to add neurons, add neurons like this to solve XOR problem, to solve nonlinear problem. So here, that is perceptron. And before we talk about the training rules of this perceptron, we may first have a view of how the information will be transferred from the input to the output. So first, we got a lot of input x1, x2, x3, x4. So these x4, we will calculate the weighted sum and come with the weighted sum and convert, and it will be the input to this neural, and we will calculate weighted sum, and it will the information from all these neurons will be will be transferred to this neural, transferred to this neural, transferred to this neural, also the neurons in the same layer. And then these neurons, or the information from these neurons will be transferred to the final output. So that is the information will be transferred from the input to the output layer. And so the aim to train a neural network, actually is to find the proper value of these weights and also the bias, weights and bias. For example, every line, this line are represent a weight that is W1, W2, W3, W4 a weight. So the goal to train the model is to find the proper weight, proper value of these weights and the bias to make the model work, So if we can find the proper value, for example, here we input a sample. So like, or what we mentioned, the sample of a house, we got size of the sample, number of bedding rooms of the sample, and the location of the sample, and other the year of this house. So these features, we input these features into, and we want the final prediction. We want the final output be the prediction of the price of the house. So here we input one sample, and we want the final output be the prediction of the price of the house. So here we will use a loss function, just like what we've mentioned. Maybe we can have a view of this. Wait a second. We can have a view of these slides. Here we got two input and the weighted sum through activation function. Here is the output for this neural, and weighted sum of these two input, and here is output for this neural. Also weighted sum and output for the fourth neural. Also weighted sum, that is y sub 5, and weighted sum. Here is a final output. That is our prediction. The price of the house may be 100, and then we will compare the prediction with the actualable. So to evaluate the difference between the prediction and the actualable, we always use a loss function. Here L means loss function. So here L means loss function to evaluate the difference between the prediction and the actualable. So how to update the weights, how to change the weights a little bit, how to change the weights and bias a little bit to make the model work. We will use back propagation. So why is back propagation? Back propagation is that the information transfer from the input to the output layer, and then we receive prediction value. So a prediction value, and then we compare the prediction to the prediction to the actual label, we got a loss function. So we can view the loss function as the arrow of the total model. So as an arrow of the total model. So the next step, what we're going to do is to back propagate the arrow. Back propagate the arrow. Here, this is an arrow, and we need to back propagate the arrow. Like here is the arrow.
If you are
Yes,
writing
please.
something on another screen, please show that screen to us.
Sorry. Here, I will explain again. Okay. Here, we got two input weighted sum, and y1 is the output of this neural, right? And weighted sum, and y2 is the output of this neural, weighted sum through a log activation function. Here is the output for this neural, and weighted sum of y1, y2, y3, y1, y2, y3, weighted sum through an activation function, and here is output y4, and here is output y5, weighted sum through an activation function, and weighted sum, and then we got the final prediction of the model, that is y hat, and then we will compare y hat with the actual label, with the actual price of the house, and we use loss function to compare the difference, to evaluate the difference between the actual label and the prediction. And here we can view this L partial Z6. We can view this as the arrow term, So we view this L, the value of the loss function, as the total arrow of the model. That is the difference between the prediction and the actual label. We view L as the total arrow of the model. So we would how to update the weights and the bias. So we will use back propagation algorithm. We will use back propagation to back propagate the arrow L to every neural. That means how many arrows this neural generate, how many arrows this neural, how many arrows will be generated here, how many arrows will be generated here, how many arrows will be generated here. So we will back propagate the arrow, use the arrow term, and use functions like this. So we use partial to determine that this neural may take how many responsibility for the total arrow. So here, that is the arrow term for this neural, and it will be back propagate to the last layer, to this hidden layer, and use this function. That is the arrow generate here times the weight here, and times the derivative of the loss function, because every time when we transfer the information, we use activation function. Sorry, not loss function. We use activation function. So here we use this function to back propagate our arrow to determine how many arrows these neurals are generated, how many arrows this neural generated. So we back propagate the arrow, that is sigma 6 to sigma 5, and that is sigma 4, sigma 5 to sigma 2, back propagate the arrow term. And then we will use this arrow term to update our weights and bias. So how to update the weights and bias? Let's have a look of the algorithm, let's have a look of how to update the weights and BIOS in neural networks. So here is the function to update the weights and BIOS in neural networks. So to explain, to make it more clearly, so here we would update our weights and BIOS use gradient descent. And it's the most commonly used. Is the most commonly used algorithm to update weights and BIOS. So for gradient descent, how gradient descent works and how gradient descent be used to update weights and BIOS. For example, here is our loss function, right? This is the loss function. We got two features, that is W0 and W1. We got two features, W0 and W1, two features. And then we can calculate the error. We can calculate the error according to the equation. We can calculate if W0 equal to 1 and equal to 10 and W1 equal to 10, and we can use the function of, we can use a model to make a prediction, to calculate the loss value of the model. So here is an example. So the loss value will be like this. We can view it as a mountain. That is our loss value. I will clear all. So for example, here is the mountain. Here is a mountain, and the height means the loss value. So the height means the loss value. What happened? The height means the loss value. So our goal is to, maybe here the first thing we randomly initialize the value of weights and BIOS. We randomly initialize maybe first time our weights are, the value of the loss function is here for the first time, maybe it equal to 100, and our aim is to minimize the value of the loss function. That is, we want to go from here to the lowest point, So that is our aim. So to update the weights and BIOS is to find the lowest point of the loss function. That is our aim. And then what we're going to do, just like we are randomly dropped anywhere in a mountain, close your eyes and you are randomly dropped anywhere in the mountain, and so now you want to find the lowest point. The lowest valley of the mountain. So what are you going to do? So the commonly used strategy is use our foot to try to find where is the steepest direction, so we can follow this direction. So we can follow this direction step by step, and finally to the local minima. So that is our strategy. We will use our foot to try every direction and to find the direction direction that will help us to find the direction that will go down the farthest. So that is our strategy. And to explain it in mathematics, we will use gradient. So for gradient in mathematics means the steepest direction. For example, we will go back to the whiteboard. So if we are random dropped here, that means in 2 dimensions, it is here. So that is the direction of the gradient. So we need to go down followed by this direction. So that is minus gradient. So that is the direction we need to update our weight and bias, followed by the opposite direction of the gradient. So here we just calculate the gradient of the loss function, and here the gradient of the loss function, and followed by here as a hyperparameter, we call this lambda. We call this lambda knurling rate. So you can view the knurling rate as the length of your foot. If you are tall, the knurling rate will be large. If you are short, the knurling rate will be roughly small. So here, knurling rate times the gradient. Here, this is a gradient. This is the gradient of mean square error loss function. This is a gradient of the mean square error loss function. And then we will update the weights. Here is a weight, W, according to the gradient, and the opposite direction of the gradient. So here is minus. So here is our strategy to update the weights. We will use gradient descent to update our weights. So for gradient descent, there are three strategies to calculate the gradient. So the first strategy is when we calculate the gradient here, we will take all the samples in the training dataset into consideration and calculate the average gradient here. We will calculate the average gradient here to calculate the average gradient of all samples here and take one step ahead to here. That is global gradient descent algorithm. So we would take all the samples in the training data set. We will take all the samples of training data set into account and then consider the average of the gradient. And so the global gradient descent would spend a lot of computing power and computing storage. It will cost a lot of computing power and computing storage. And so, but it is very stable. And for the stochastic gradient descent algorithm, it means every time when we calculate the gradient here, for example, if our loss function is like this, so the gradient that is partial, that is x. So here x, and to calculate the gradient, we will randomly pick one sample from the whole training dataset. So that is stochastic gradient descent. We will randomly pick one sample from the whole dataset to calculate the gradient and then to update the weights and bias for model. That is stochastic gradient descent. So compared to global gradient descent, stochastic gradient descent will not be that stable. Because with stochastic, we randomly pick one sample to calculate the gradient. So here, the third type of gradient descent algorithm, we call it mini batch gradient descent. So for mini batch gradient descent, mini batch gradient descent is an algorithm in between global gradient descent and stochastic gradient descent. That means every time when we calculate the gradient at this point, we will randomly pick a small batch of samples in the training dataset. That means we may randomly pick 16 samples, or we may randomly pick 32 samples. So here, the size of these mini batches, we call it batch size, and usually it's a hyperparameter. We need to decide, maybe I will write here. So for mini batch gradient descent, there is a hyperparameter, we call it batch size. So batch size usually, so the value of batch size usually depends on your computing power and the computing storage. For example, we can assign the value of batch size as 16, 32, or 64, or 128, and so on. So that is batch size. So if batch size equal to 16, that means every time we will use 16 samples to update the weight and bias. So that is gradient descent. So it's just like we are blind. We are blind, and we are trying to find the lowest point of the mountain, and we use our foot to check the direction, and we will follow the direction. Now we will follow the steepest direction. We will follow the steepest direction and go to the lowest point step by step. That is gradient descent. Then there are three types of gradient descent. That is global gradient descent, stochastic gradient descent, and mini batch gradient descent. And then the next section, what we're going to talk about is activation function. So for activation functions, we've mentioned we always, after the weighted sum calculation, always we will add activation functions to mainly, the aim is mainly to add the nonlinearity of the model. So there are different types of activation functions. For example, the first type of activation function is a sigmoid function. So in logistic regression, we will use sigmoid function, right? We will use logistic regression as a sigmoid function, and here we can use sigmoid function as an activation function, and the red line is the sigmoid function, and the dashed line is a derivative of this sigmoid function. And you can have a look of this derivative of the sigmoid function. So when the value of the input is larger than 2 or smaller than -2, the derivative of this sigmoid function will be very, very close to 0. So let's have a look of the, wait a second. let's have a look of the equation here. When we backpropagate the arrow, we would use the derivative of the activation function. So if here the derivative of this activation function is very close to 0, that means here this arrow term will be very close to 0. So that means when we update the weights and the BIOS, when we update the weights and the BIOS here, this term, so this sigma will be very close to 0. So that means this term will be very close to 0. That means these two weights are very close. That means the model didn't improve this time. So that is the problem of sigmoid function. And always the feature of sigmoid function is that the sigmoid function can map any input into the range of 0 to 1. So like the probabilities. So the sigmoid function always work as a gate function. So always work as a gate function. That means because it can map any input to 0, from 0 to 1. That is sigmoid function. And another types of function, the second type of function, activation function, is the test function. So here the red line is a test function, and the dashed line is also the derivative of the test function here. So for the test function, the largest value of the derivative equal to 1, and for the sigmoid function, the largest value of the sigmoid function just only 0.25. So that is another problem of sigmoid function. The largest value of the derivative of its derivative is just 0.25. That means if we use sigmoid function, that is 0.25. This theta 5 will be smaller than will be smaller than theta 6. So here is a test function, the maximum value of its derivative equal to 1, but it has the same problem. That is if the input value is greater than 0 or smaller than greater than 2 or smaller than -2, the derivative of the test function will be very close to 0. That means the weights cannot be improved. The weights cannot be updated. So if the weights cannot be updated, that means the model cannot be improved this time. And the next one is the variance of test function. That is a soft sign function. So it's very similar to this test function, but the equation is more simple. So for these three functions, we usually use sigmoid function as a gate function, and in natural language processing or speech processing task, usually we will try test function. We will try test function as the activation function or the variance of test function. And the next function we're gonna introduce is the ReLU function. So here is an equation for ReLU function. So compared to the activation functions we introduced just now, the equations of the ReLU function is much more simple. It's much more simple than these three activation functions. So, oh, sorry. Where are you? So for value function, usually in computer vision task, for computer vision model, we will use
I have a question. I'm sorry to disturb you.
Yes.
Why are we studying these type of functions? I mean, like we just studied almost like 4 to 5 type of functions. But what is the main reason behind that? Like, the main objective behind these functions.
You mean what? Why is the reason?
Hello.
Yeah. Yes, please.
Yes. I'm asking that why are we actually studying these type of functions? Like, what's the main purpose behind that? Like, their objective behind these functions in artificial intelligence.
Okay, because the activation function, because in the neural networks, after every weighted sum calculation, we would use activation function. So actually, usually the activation function is a must for deep neural networks. For almost every deep learning model, we will use activation function, and how to choose your activation function, whether you want to use single mode or test function or soft side function or value function. So we have to be familiar about these functions. So that you can create your model. Because if you create a model, you need activation function.
Thank you so much.
Yes.
I get it.
So activation functions exist in almost every deep learning model. So to create a model, we need activation function to add the nonlinearity of this model. So here is a value function in computer vision model, computer vision task. Usually the first choice of the activation model of the activation function is the value function, and it's very easy to compute. And usually for computer vision task, the image is very large, especially for some high resolution image. So it contains a lot of pixels. So we will prefer to choose a very simple activation function. So here, first, we will try value function. Yes, please.
Can we use grid search for the best activation function?
Yes, but usually activation function, you can use grid search to search for your activation function, but usually we will not do that because just like the law we induced for activation function, we will try value or the variance of value, and for the models related to natural languages, related to sequential data, we will try the test function or the variance of test function. So that is just like the law. We will try value first for computer vision models. And yeah, it's here the solid line, the red line is the value function, and the dash line, the dotted line is the derivative of the value function. So it's very simple. If the input is larger than 0, if the input is larger than 0, it's larger than 0, and we can try it larger than 0, the derivative equal to 1, otherwise the derivative equal to 0. And here the soft plus is the soft plus and is the variant, is a variant of value function. Here the green line is the soft plus and the blue line is the value, So it is a smoothie. It is a smoothie function, and also it don't have the date zone. So it don't have the date zone for value function if the input is smaller than zero, the output will always be zero, and also the derivative will always be zero. So that is the date zone. That is the date zone of the value function. So that means if your input is smaller than zero for this neural, and now we use value function, and the neural will be date. The output will always be zero, and the derivative will always be zero. And so we introduced the soft plus function here. So the last activation function we're gonna introduce is the softmax function. So for the softmax function, here is the equation, and softmax function is a function like this. It can map a k-dimensional vector to another k-dimensional vector, but the feature of this output k-dimensional vector is that the element in this vector would be range from 0 to 1, will be in this interval 0 to 1. And if we add all elements together, the final output, the sum will be 1. So let's have an example. Clear all. For example, here we got a vector. It will be maybe 1, 1, 2, 100, 2, 1, 1. Here is our vector, and we can use a softmax function. We can use a softmax function to map all these elements to the interval 0 to 1, and if we add them together, the final result will be 1. For example, the output may be like this, 0.01 or like this. So this just like the probability. I will use an, okay, this will be better. For example, here is the input. And after the softmax function, the output vector also is a k-dimensional vector, that is 7-dimensional vector, but the value will be like this. And here may equal to 98. And if we add all these elements together, the final result will be 1. So it's just like the probability. For example, if we do digital recognition problem, if we want to solve the digital recognition problem, so we input some digital images from 0 to 9, and I will use this one. We input some digits. We will input some digits, 1, 2, 3, 4. A lot of images with digits, 1, 2, 3, 4. A lot of images with handwriting digits. And so for this model, the purpose of this model is to recognize the digit in the image. So the output of this model always be a 10-dimensional vector. So always be a 10-dimensional vector. So every element represents one value, one digit. Maybe the first represent 0, the second represent 1, and the third represent 2. So if we use softmax function, activation function, we can map this 10-dimensional vector. 10-dimensional vector into into vectors of possibility, Just like this. This is an example. So that we will choose the highest value. We will choose the highest value. Here, the second element got the highest value, so the output will be 1. So the output will be 1. So that is softmax. That is softmax activation function. We will map the vector. We will map the vector, and every element in this vector maybe represent the score of every category of every class for image classification function. But after softmax function, every element in the vector would represent the possibility of this class. So the original vector, so the elements in the original vector may be minus 1, minus 10, minus 100. That is the score for the corresponding class, and we use softmax function to map all these elements into the interval 0 to 1. That is softmax function. So usually softmax function are used at the output layer of multi-class classification problem, just like the example we've given. So that is softmax function usually be used at the output layer, in the output layer, and it's always a multi-class classification model. So that is all the activation function. We mentioned the sigmoid function, and also the ReLU function, the touch function, and the soft sign, and the soft plus, the variant of ReLU function. And for image classification, for tasks related to computer vision, we would always try ReLU function and its variants first. And for some sequential data, we may always try touch function or the variant of touch first. And here, the next topic we're gonna talk about is the types of neural networks. So here we're gonna talk about the types of neural networks, like the multi-feedforward neural networks, and the multi-layer fully connected neural networks, and the multi-layer perceptrons and convolutional neural networks. So first, the first type of neural networks we're going to introduce is feed-forward neural network. So for feed-forward neural network, the keyword is feed-forward. What does feed-forward mean? Feed-forward means the information would only transfer from the input layer to the output layer. It only transferred forward. There's no backward route. There's no backward route. It only transfer from the input to the output. That is feed-forward neural network. So here is an example of multi-layer fully connected neural network. So what is fully connected artificial neural network? Here, fully multi-layer means there's a lot of hidden layers, and here fully connected means every neural would receive information from all the neurons from last layer. So that means this neural will receive information from all the neurons at this layer, and this neural at the hidden layer 2 would receive all the information from hidden layer 1. That is fully connected mean. So that is an example of layer fully connected neural networks. So here we can also call it multi-layer perceptron, that is MLP. That is an example of multi-layer perceptron. So every neuron will receive information, all the information from last layer. Every neuron will receive all the information from last layer, and it's a feed-forward neural. It's a kind of feed-forward neural. That is multi-layer perceptron. And then what we're gonna talk about is the convolutional neural network. So for convolutional neural network.
Sorry,
yes,
I have
please.
a question from the last slide.
Yeah, you mean this slide?
In the outward layer, how many neurons we can have?
It depends on your task. It depends on your task. For example, if the problem you want to solve is a binary classification problem, right? If it's a binary classification problem, the neural at the output layer may be 1. There's just 1 neural, so the output could be 0 or 1. But for example, if you want to solve problems like what we mentioned, like the multi-class problem, so we want to do image classification. We want to solve an image classification problem, and in the training data set, there are 1,000 classes in total. So here, the neurons at the output layer will be 1,000 neurons at the output layer. So that is an example.
So it means that it depends on the number of classes we have in data.
Yes.
But for binary class, we may have one neuron.
Yeah, for binary class, we may have 1 neuron. Yes.
Okay. Thank you.
Okay. So here, the next type of neural network we're going to introduce is convolutional neural networks. And convolutional neural networks and also is a feed-forward neural network. That means the information would only transfer from the input to the output layer. And here we may have a look of this slide. And here is an example of convolutional neural networks. So here is the architect of the convolutional neural networks, and we will introduce them in details. So for convolutional neural networks, usually it will contain 3 types of layers. First is convolutional layer, and the second is pooling layer, and the third one is fully connected layer. So for example, for these convolutional neural networks, the output layer contains 10 neurons. And we use softmax activation function. So this is a model for multi-class classification, and the final output is a 10-dimensional vector. So we want to recognize 10 classes. So we want to recognize 10 classes. So the convolutional layer is mostly used. Sorry. So in computer vision, so convolutional neural networks got a very excellent performance in especially computer vision, or especially in image processing, because for convolutional neural networks, it can extract the information from the image automatically. But if we use some traditional image processing algorithms, we need to design our feature descriptors. We need to design our kernels to extract informations. That is not the automatic process. That is the manual the manual process, we need to design our kernel to extract features from the image. But for convolutional neural networks, it can extract features from the image automatically, and then we're gonna figure out why it can extract the information from the image automatically. So first, we just mentioned convolutional neural networks always contain 3 types of layers: convolutional layer, pooling layer, and fully connected layer. So let's have a look of them one by one. First is convolutional layer. So for convolutional layer, first thing we're gonna talk about is the convolutional calculation. So convolution, the first time it's introduced in information theorem. So this is the equation for convolution, and this is the equation. This is a discrete convolution calculation. This is a discrete convolutional calculation, and this is the convolutional calculation in deep learning. So to put this equation into perspective, so let's have a view of this figure. For kernel convolution calculation in CNN, we will calculate the convolution operation like this. Here we got an image. So we got an image. This image is a 5x5 image, right? So to calculate the convolution, always we got a kernel. We got a kernel or filter. We got a kernel or filter. Here, this I means the input image, and this K means the kernel. So this is the input image, and this is a kernel, right? So this is a kernel. So what we're going to do is to calculate the weighted sum. Here, what we're going to do is calculate the weighted sum. The weighted sum of the image and the corresponding kernel. So, and the kernel would scan the entire image like this. So here is the example. That is, we will do multiplication 9 times and add these 9 numbers together. This is one output, and the kernel will scan on the entire image, or the kernel will scan on the entire image. So the output would be like a 3x3 matrix, and always we will call this output feature map. So that is a map contains a lot of features. So that is the kernel convolution. That is a kernel convolution. So for images, especially colorful image, it's not a colorful image. It's not a single channel image. For example, wait a second. Okay, here is a sample of grayscale image, right? Here is an example of grayscale image, and if we put this image into computer, here is the image in computer. It's just a matrix, right? So every pixel got a value, got a intensity, got a value, represent its intensity. And this is grayscale image. It's a single channel image. And for color image, color image is no longer a single channel image. It's a multi-channel image. And we got a lot of different color spaces, and the most commonly used color spaces is the color spaces we call it RGB. We will be very familiar to these color spaces. RGB, so R means red, and G means green, and B means blue. So for color image, it's multi-channel image, and for RGB image, it's 3-channel image. It's a 3-channel image, and we combine these 3 channels together, it becomes a color image. So the example we just viewed is an example of grayscale image, right? Of grayscale image. And if we want to do convolutional calculation on a corner image, so here is an example. So for RGB image, it got 3 channels. That means it got 3 matrices. The first matrix, the second matrix, and the third matrix. So how we do convolutional calculation? We will do convolutional calculation like this. So the image is a multi-channel image. So the filter is also multi-channel. It's 3 channels. The filter got 3 channels. The filter got 3 channels. So this channel, this matrix will be responsible for this channel. This matrix will be responsible for this channel. This matrix will be responsible for this channel. So it will do convolutional operation, that is a weighted sum. That is the weighted sum, and the kernel will scan the entire image. And so here is the output will be a number. The output will be a number, right? The output will be a number. The output will be a number, 3 numbers. So we are doing weighted sum. For example, if the kernel, for example, if the kernel is here, 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 so we do weighted sum. We do weighted sum. 0 times minus 1, 0 times 1, 0 times 0, and add these 9 numbers together. Here is 1 number, the second number, the third number, and we add these 3 numbers together. We add these 3 values together, plus the BIOS with the filter. Here is the 1 output. Here is one value in this feature map. Here is 1 value in feature map. So the kernel can scan the entire image. The kernel can scan entire image and output a lot of values, and we combine these values as a matrix. So here is the multi-channel. Here's a multi-channel convolutional calculation. And also at a single convolutional layer, we can use a lot of kernels. For example, at the first convolution layer, we can use maybe 10 kernels or 20 kernels or 100 kernels to do convolutional calculation. For example, here we use kernel W0 to do convolutional calculation and received and get 1 output and get 1 feature map. We can use another kernel, that is W1, to extract information from the image and receive and get 1 feature map. So here we use 2 kernels, and the output will be 2 feature maps. So that is multi-kernel convolution calculation. So here are some terms we need to be very clear about these terms. For example, here image, the size of the input image actually is 5 by 5. It's 5 by 5 image. And here these three means 3 channels. We got 3 channels. That is RGB image. And here another term, the first term, we call it padding. So what does padding mean? Any idea about what does padding mean? No. Okay. Wait a second. Okay, I'm sharing these white slides. So for padding, that means if our kernel locates here, so, and we wanna extract informations on the boundary of the image. If we don't pad, so there is no value at here. There's no value at these pixels. There's no value at these pixels. So we cannot do convolutional calculation. at these boundaries as these boundaries of the image. So we need to pad. So if we pad, we can do convolutional calculation around the image. We can do convolutional calculation around the image so that we can scan, we can extract informations as these boundaries. So here, that is the meaning of padding, and padding equals to 1. That means we will add zeros like this, just like a circle. That is padding equal to 1. And always when we talk about padding, it's always 0 padding. That is, we will add 0 around the image. We will add 0 around the image. So that is padding. And the next is convolution kernels. So the size of the convolution kernels here, we got 2 convolutional kernels, right? We got 2 convolutional kernels. This is the first one, and this is the second one. So the size of each convolutional kernel is 3 by 3. So this first 2 3 by 3 means the size of a matrix, and the second 3 means the channel of the kernel, So here, this 3 is equal to these 3, right? And another term we're gonna introduce is stride. So stride means we will do, stride equal to 2 means we will do convolutional operation every 2 pixels. So for the first time, maybe the central point, the first convolutional calculation, the central point may be here, the first 0, and so the next time the central point would move to here. This the second one, not the first one, the second one. And then the central point will be moved to here. That means we will do convolutional calculation every 2 pixels. So that is right. And the feature map, that is the size of feature map, 3 by 3. So the first feature map, the size is 3 by 3, and we got 2 feature map because we got 2 filters. So the size, so that is the meaning of the last 2. So that's multi-kernel convolutional calculation. So that is how we do convolution on an image. Any problem about these slides? Any problem about these slides?
Yes, I couldn't conceive its proper meaning, but I'll just see the recording afterwards. You should carry on.
Okay. Okay. Time's up. Maybe we can, tomorrow we'll continue to talk about the convolutional neural networks and why it can extract information from these images and the main concepts of the CNN. Maybe we will continue to talk about this knowledge tomorrow. So that's all for today. Yes, please.
Can CNN only be applied on images datasets?
Yes.
Not on normal datasets. If we make arrays of them, and
what is normal dataset?
Like a dataset like Boston housing dataset, like any other dataset. There are 2 datasets, images datasets.
Usually, the convolutional neural networks CNN can be used most in images, can be used for images. Also, we can use CNN to process some sequential data. Also, actually the function of CNN is to extract information, from image or from sequential data. We can use CNN to process like the voice, like the voice of like the voice signal. It also means to, it also can extract information from this voice signal from these radios. But for the what you mentioned, like Boston, the house price, this kind of information, we will not use convolutional calculation.
I want to add, Kelsey, some information here.
Yes, please.
CNN can be used for image or computer vision tasks or speech, voice. It can also be used for numeric data like the Boston data set, but it cannot perform well since CNN extract feature by automatically, and
Yes.
When we will use CNN for dataset, numeric dataset like Boston, we have to do some kind of encoding, maybe one hot encoding or some other type of encoding. But I found that CNN could not perform well on those data sets.
Yes.
So it is better, or it is most recommended to use CNN for image, voice, audio, video, such related tasks.
Yes. Any other question? If there's no more question, maybe that's all for today. If you have any other question, you can send email to me. Okay, thank you so much. Okay, that's all for today. Good luck. Bye.
Okay, thank you.